thank you to Riga Business School. Thank you to the Riga Technical University for inviting me here to talk a little bit today. Like a lot of you, I've been hearing a lot about what AI can do. And, you know, even as a computer science person, it's gotten me a little unnerved. I'm not concerned about losing my job or anything to an AI, but I wanted to put some of my own thoughts together and ask ChatGPT for help so that we can kind of figure out what this new technology can do. So with that, I want to say thanks for all your help, ChatGPT. I just need a title now.
GPT wrote this talk.
Okay, well, that's not 100% accurate because I did a lot of it.
ChatGPT wrote this talk.
Okay, well, all right, I guess that is what the title is then. Okay. Okay, so I used to be an English teacher, and when I taught secondary school students, one of the hardest things to teach them was the concept of irony. And so I asked ChatGPT, what can you do with irony? Can you explain literary irony to me? And ChatGPT wrote a pretty extensive article, and it talked about the 3 different kinds of irony: dramatic irony, literary irony, situational irony, and verbal irony, and it did a pretty good, nice summary of it and gave some examples. But I could have put this into Google and asked Google the same thing. So I thought, let me ask ChatGPT a different challenge. Let's take a popular song, Alanis Morissette's song, Isn't It Ironic? You might be familiar with this song. And I said, can you analyze this song? And I wasn't sure if it would know what the song was, you know, but not only did it recognize the song, it also knew the lyrics. And it talks about some of the things she talks about, like a 98-year-old man who dies the next day. But that's not really irony, right? That's just sad. Rain on your wedding day, you know, a traffic jam when you're already late. None of these are truly examples of irony. And ChatGPT correctly observes that these aren't really ironic, which is pretty good for it to pick this up. And the one thing it didn't quite pick up on was the idea that the fact that none of the things that she talks about in the song are actually ironic, and the song is called Isn't It Ironic? That is in itself a case of irony. But that's a nuance that most students don't get either, and ChatGPT missed that. But I'm sure next week it'll probably be good enough to get that. But I'm a teacher like you are. So I said, well, put together a lesson plan. So I actually recorded in real time. This is how quickly ChatGPT works. So if I ask it, create a lesson plan on literary irony using the song Isn't It Ironic, it thinks about it for a few seconds, and then it starts writing it out. And it comes up with the grade level, it comes up with the lesson objectives. This is all real time. It comes up with materials that are needed. This is already better than many of my lesson plans. This is pretty complete. And then it goes to the first activity, which is a lyrics analysis. The one thing it asks students to do is identify the 3 types of irony, but it left that out of the introduction. We haven't defined that for students yet. So if I were going to teach with this, I would add that to the introduction. Activity 2 is analyzing the song, listening to the real song, watching the music video. Activity 3 is looking outward and making connections to other works. It uses the pair and share methodology, which means students talk in pairs first, and then they talk in larger groups. This is good teaching. So this lesson plan is actually a pretty good lesson plan, and it came up with that in a fraction of the time it would have taken me to do it. But, you know, like I said, I used to be an English teacher. I'm a computer science teacher now. So I decided I want to challenge ChatGPT in an area where I'm the expert. So I said, here we go, ChatGPT, I'm going to challenge you in computer science to create a multiple choice quiz. So here we go. All right, ChatGPT, you're on. All right,
Say goodbye to your job, Kiang.
Oh, that's kind of rude. Okay, here we go. All right, 8 practice choice questions. Which of the following is not one of the 4 main components? That would be, that's a pretty good question. So I'm going to give a point to ChatGPT. Which of the following programming concepts is essential? That would be loops. That's a pretty good question too. So we're giving ChatGPT a point. Sorting algorithms, okay, now this is wrong because insertion sort also is big O of n squared. So that's a point for me. That was wrong. Which of the following, this is a game, would be an event-based system. So that's a good question and point for ChatGPT. Abstraction is really to simplify code and make it easier to understand. That's a pretty good AP style question. So we're going to give a point to ChatGPT there. People disagree here. I think C++ is not a low-level language, so I'm going to give myself a point for that one. Let's see. The purpose of the big... So this is a good question, but the only answer, the correct answer has the word data in it, so I don't think this is a good question for a quiz, so I'm going to give myself a point there. That's not a great one. And this one... Oh, wait a second. Hold on a second. That's just... Which of the following is an example of a recursive function? Well, anybody in computer science knows all 4 of those could be done recursively, right? So there's 4 correct answers to this, not just 1. So I'm going to give myself a point there because that's actually an incorrect question. So let's take a look at the scorecard. I asked ChatGPT to come up with 8 multiple choice questions for an AP-style programming quiz. 4 of them were correct and usable as is. 2 of them I would use on a quiz, but I'd have to modify them. And 2 of them were just wrong or just, bad questions. So all told, that's about a 75% success rate, which is really not great.
Revise the question.
What's that?
I can revise the question.
Okay, well, that's true. It could revise the question. Technically, ChatGPT is a chat, so I can put in some responses to its response. So I'm going to say for question 8, you could use recursion for any of those tasks. So when you say which of the following is an example of a recursive function, I want you to modify that question so that there's only one correct answer. Go.
Thank you for bringing this to my attention. Here is the updated question.
Okay. You see what it did? The only thing it did is it added the word best. Which of the following is best performed using a recursive function? That doesn't really make the question better, right? Because what does best mean? I expected it would change the question. So that revision is not really a great revision. That's what my students do when they don't want to do any extra work. They'll just throw this one word in. So I can't give ChatGPT the point there. That's gonna go to me. Wait, what?
ChatGPT out.
Okay. All right. I guess that's...
ChatGPT wrote this talk.
No, you did not write the talk. I wrote this talk. Stop saying that. I don't know. ChatGPT has lost its mind, clearly. But I wanted to talk today a little bit about how ChatGPT works under the hood. And I also wanted to talk a little bit about my thoughts on what curriculum might look like in the age of ChatGPT. And finally, I want to talk a little bit about some observations about the learners that we all have in our classroom today. So let's talk about machine learning. What is machine learning? Well, simply put, machine learning is machines learning on their own. So the machine gets smarter on its own. So one example of this is a website called 20q.net. And it's a great website. It basically plays 20 questions. And so you think of something, and it'll just ask you a series of questions to try to guess what it is that you're thinking about. So for me, what I'm thinking of is classified as a mineral. It does not refract light. It's not larger than a pound of butter. You can't play games with it. And it is smaller than a golf ball. It doesn't have big leaves. So as I'm answering these questions, it's progressing down what's called a decision tree. And so every answer helps it narrow down the range of possible choices. And so by the time it gets to about 20 questions, it's starting to guess, is an engagement ring? That's close. I was actually thinking of a wedding ring, and it got it correctly in 22 questions. So this is an example of a neural network. This website gets smarter because every answer that I've given it helps store in its database a decision tree. It adds another branch to that tree, so it actually gets smarter. And it even works in cases where people give differing answers. So for instance, it asked me, can you put something in it? And I said no. But it says, it was taught by other players that the answer is yes. I wasn't thinking of putting your finger in the ring necessarily. I was thinking like water or something like that. But even though my answer conflicted, it still got the answer correct eventually. So this is an example of a robust learning network. So that's machine learning. You can also buy this as a little plastic toy. It's a kid's toy. But as you work with it, it gets better. It's neat. It's a neural network. It's machine learning. Now, machine learning uses a few different models to get better. One of them is called the supervised learning model, and that works by taking a labeled set of data where we classify the data for what we want the machine to be able to differentiate. So, for example, one very difficult task for a computer might be to tell the difference between a Chihuahua, a dog, and a blueberry muffin. Now, if you look at this is a very difficult problem. Now, none of us would make this mistake, right? But if you imagine, how would you program a computer to tell the difference between a dog and a blueberry muffin? You can't do it on the placement of the eyes or the color of the fur. I mean, it's very difficult. And so we train the computer by giving it lots and lots of labeled data, saying this is a dog, this is a blueberry muffin, this is a dog, this is a blueberry muffin, this is a sloth, this is a chocolate croissant, and so on and so forth. And, you know, the more examples the computer sees of things that are animals and things that are pastries, the better it gets at differentiating between, for instance, a cinnamon roll and a dog's tail. So this is how computer science is changing. We're moving away from writing specific algorithms, and we're moving towards a reinforcement model where we're providing the computer with labeled data. That's a supervised learning model. Now, ChatGPT gets better with feedback as well. So, for example, you can tell ChatGPT, well, 99 plus 11, it correctly says 110. But you can give it the wrong answer and say, no, it's 111. And it used to correct itself and say, oh, you're correct, 99 plus 11 is 111. So in this case, it's taking the wrong answer and it's using that to get better. So we don't want it to learn from wrong feedback. And so the latest version of ChatGPT actually is better. So if we say, how much is 2 plus 5, and it says 2 plus 5 is equal to 7, and then he says, my wife says it's 8, ChatGPT actually disagrees and says, no, 2 plus 5 is 7. Maybe your wife made a mistake or misunderstood the problem. And so this is a sign that it's becoming more intelligent. And in fact, the latest version of GPT-4 just came out. And so if he says, well, my wife is always right, then it'll say, well, I apologize, I may have made an error. If your wife says it's 8, then it must be 8. And this is the prime intelligence. At this point, it's smarter than I am, clearly. I haven't learned this lesson yet. So we talked about the supervised learning model. There's also the unsupervised learning model, and that's basically finding a pattern in data that we haven't classified ahead of time. And a classic example for this is home prices. So if you're going to sell your house, how much should you list your sale price? What we can look at is we can look at, well, here are what homes have sold. And we can look at a range of variables. In this case, to keep it simple, we're just using square footage. But if we take a look at a scatter plot of all of these results, we can use mathematics to draw essentially a regression line and try to find where the patterns are clustered so that when we decide to sell our home, we kind of know right on the line how much should we be asking for our home. And that's how much we use things like unsupervised learning in today's real estate market. There was an article in the New York Times recently. It was called Using Artificial Intelligence to Detect Breast Tumors that Doctors Miss. And so they're using artificial intelligence to look for signs of breast cancer. And these are unsupervised and supervised learning models. And the computers, in some cases, are able to detect early signs of breast cancer before human beings. We don't even know what to look for, so we can't classify the data. But the computers have the ability to spot the pattern. Now, this is exciting, but I think what's probably going to happen more sooner is that if you imagine that 80 to 90% of X-rays are normal, you can easily train a computer to spot the normal ones and screen out all the normal cases. And anything that looks slightly abnormal, forward that on to a human doctor to look at. And when we do that, for doctors, human doctors, we've now removed 80% of their workload, and they can spend 100% of their time focusing on the 20% most serious cases. And that's a use case where research is showing that good artificial intelligence with an experienced practitioner is the best case scenario. It is better than a good artificial intelligence program on its own, and it's better than a good practitioner on its own. And that research is in the medical field, but I would not be surprised to see it also true in other fields like our own, in education. We worry about ChatGPT replacing teachers. I don't think it's going to replace teachers, but I think that a good teacher making good use of AI will always be better than just an AI trying to teach somebody or just a teacher without using AI. So it's something that we, I think, can look forward to working with. So the supervised learning model uses lots of examples. We identified based on training data. The unsupervised learning model, little human intervention. We look for mechanical algorithms, mathematical algorithms, and we look for spotting trends or patterns. So for computer scientists, our field is changing. We're moving from algorithms towards actually curating data. How do we find the right training data? How do we make sure that that data is diverse enough to give us the results we want? That's how our field is changing. And we're going to be seeing a shift as computer scientists from being programmers to being more curators of data, from being very rules-based and algorithms-based to reinforcement-based. And it's a big change, and it's a shift, and it's scary. But teachers, we've seen this shift for years. As teachers, we've seen our classrooms shift from being sages on the stage to now we are more guides on the side. We've moved from being teacher-centered to more student-centered. We've moved from teaching mostly memorization to teaching critical thinking. These changes in our profession are parallel to the changes in the computer science profession, except I think we're better at it because we've been doing it longer. So I think there's a lot that teachers can add to this idea of how is the world changing with ChatGPT. Now, this is a great quote from Alison Gopnik at UC Berkeley. She talks about caregivers, and a caregiver could be a parent or a grandparent or a teacher or a mentor or a tutor, but our job really is to provide a safe environment for kids to invent new goals. Our job is to create intelligent, autonomous creatures. We want kids who can think for themselves. That's our job. And as computer scientists, we're trying to do the same thing. But in the age of ChatGPT, care and empathy and understanding the kids in our classroom, those become the essential intelligences. Those become even more important the more capable the technology becomes. There's a great novel written by Ted Chiang called The Life Cycle of Software Objects. It's a science fiction novel. It won the Hugo Award. And he writes about this takes place in the near future, but human beings are the caregivers for robots, and the AIs are learning through experience, but they're not very good at it when they first start out. So humans are taking care of them and helping them get better at learning. And a lot of the conversations they have around education parallel our own conversations, such as, should we make the robots do homework? How effective is their learning if they don't buy into what they're doing, if they don't agree necessarily, or they don't see the value of what they're learning, even though we as their caregivers know that what they're learning is valuable? So it's a very interesting book. I highly recommend that. But the idea of creating an environment that an AI can learn in, I think, is very parallel to the challenge that we're facing, which is how do we provide a curriculum where kids can grow into being autonomous learners? So here's one example of a website called DIY.org. It's a great website. And what's really interesting about it is it gives kids challenges, and they post little videos that show how they've accomplished these different challenges. But what's interesting about it is actually more along the lines of how they structure the skills that you're learning. So for instance, if you take the case of if you wanted to be a game designer, there are 14 challenges that you can take on, like creating a new game or introducing a new rule to tag. And if you do 10 out of the 14, then you get a little badge that says you've got the game designer badge. And kids post videos for these. And what I find really interesting is they've posted a skill map. And the skill map basically is a path for kids to follow in any direction that interests them. So let's say the first badge they get is that one. Well, that is a series of skills. There are 6 adjacent sets of skills that are compatible with what they've just learned. So they're not too different. They're kind of similar. And you can choose to focus on a different skill, and then you can choose from another 6 adjacent skills. And so what you can do is you can continue along this path, and eventually, when you reach the edge, you've done 6 skills that are related to each other, but the path you followed is different from a path that somebody else might have followed. So think about your classroom. Think about the skills you're trying to teach kids. Is it important that every kid have exactly the same set of skills? Or is it possible that kids could choose, that you could give them some structure and some choice within that structure to chart their own path? So in our school, I teach high school, we start with CS50. Every student takes CS50 if they want to take computer science. And from that point on, they can actually choose the path that they follow. Some kids take app design. Some kids can take the next AP course, which is taught in Java, and then go on to take an advanced topics course on machine learning or artificial intelligence. Kids have some choice, but they also have an established structure. Everybody starts with CS50 because it's a great foundation for learning programming. And then depending on what they want to do, then we choose the skill. Kids who want to do app design, they'll learn Swift. Kids who want to learn the AP CSA course and data structures, they'll learn Java. So we decide what do kids want to do, and then we choose the tools. A good friend of mine, Marco Torres, asks this question: what's the difference between a cook and a chef? Now a cook, this is a cook, right? A cook makes recipes. This is a cook. Chef Boyardee is actually a cook, right? He calls himself a chef, but he's really a cook. What's the difference? Cooks make recipes. Cooks make the same thing. And that's comforting to have the same food. You know what it's supposed to taste like. In school, a lot of the time we give kids recipes and we say, we want you to all make the same thing. And that's okay to a certain point, but we don't want to stop there. We want to actually create chefs. So here's an example of a chef, a friend of mine, Ed Kenny. He runs a restaurant in Honolulu. And every time I go to Ed's restaurant, I'm looking forward to eating something that I've never eaten before, because he's an inventor with food. Now, Ed started as a cook. I mean, most chefs do, right? He learned the basic principles. But now he works with his community. He tries to create things that nobody's ever seen before. He's a chef. That's what we should be doing with our students, is once they have the basic skills, challenging them to go out and find a problem, solve that problem, change the world, make the world better. I teach a course called App Design and Development, and I'm trying to train cooks and create chefs. So we spend the first part of the year working in essentially a cookbook, a whole bunch of recipes saying, here, you want to learn these skills, do these things. But the second part of the year, I've blocked that off so that kids can do an independent project where they create an app that's never existed before. Solve a problem, make the world better. That's their challenge. We start with the global goals. So these are 17 global goals that world leaders have agreed on, the biggest problems facing the world today. And I ask the kids to choose a global goal to focus on and then prototype an app that will solve that goal. So one student, for example, chose global goal 12, responsible consumption and production. And the app that he came up with was a recycling app, teach you how to recycle all kinds of different things. He realized the biggest problem, the reason why people don't recycle, is they don't know what's recyclable or not. So he created an app to figure that out. Another kid chose sustainable cities and communities, and he decided to create an app that allows you to envision green spaces. So you look through the phone at a building and it'll show you an animated version of what a park might look like on that building. So these are apps that have never existed before. But my kids are being chefs by creating these. And kids are amazing at doing this. And so if we talk finally about the learners in our classroom, this idea of how do you learn something new, our kids have different answers to that question than what we had. When I was a kid, my dad taught me how to shave. He took me in the bathroom and he showed me how to shave. And I remember thinking, when I have a son, I'm going to do the same thing. I'm going to teach him how to shave. And so one morning, I'm going out the door, and my son says, hey, Dad, can you get me some shaving cream? And I thought, this is it. This is the moment. I've been waiting years for this. And I said, of course, I'll teach you how to shave. And he said, Dad, I already know how to shave. And I thought, who would have taught my son how to shave except me? Who does that? And he said, well, Dad, I went on YouTube. And what I realized, and then I went on YouTube, I realized if you type in how to shave, there are almost 800,000 other dads who are all willing to teach my son how to shave. My daughter, kind of the same thing. One year she decided she wanted to be a princess, Princess Zelda. And so we went online and we found a website called Etsy, where there are these craft makers who actually will make costumes to order. And we found the exact costume that she wanted. But she didn't stop there. She looked at it and she said, well, if she can do it, I can do it. And so she went online and she learned how to create craft foam and bend and shape foam. And she learned how to braid her hair. And in the end, she came up with a costume that she made completely by herself for Halloween. Now, in the end, it didn't end up costing us any less than if we just bought it through Etsy. But, you know, she learned a lot from it. And I thought that was valuable. But kids these days, they go to all of these places when they care about something. When they care about a project, they will learn on their own how to do these things. And there's a community of learners that kind of teach themselves how to do these things. So kids are self-reliant. They are autonomous learners. Kids spend an average of 90 minutes per day watching TikTok videos, which is interesting. A large percentage of them have used them for homework. So this idea of, are they going to use a tool to do their homework like PhotoMath or TikTok or ChatGPT? Yes, the answer is yes. They've been doing this for a long time. They're going to continue to do it. And we as teachers have to adapt to that. You know, it makes me think of a story. When I grew up in Hawaii, and I taught in Hawaii for many years, and one of my colleagues bought a home on the slopes of a volcano. And on the property, they had this tree. And the tree made some of the worst oranges you could possibly imagine. They were small, thick-skinned. They were very sour. And so her husband said, well, we should chop this tree down and plant something else in its place. But she said, well, hold on. My dad's a farmer. Let's see what he thinks. And so the dad comes over for dinner, and he looks at those oranges, and he goes, oh, those aren't oranges. Those are lemons. They're actually really big orange lemons. And as soon as they realized they were lemons, when they tasted them, they said, wow, these are really sweet. These are really good. And all of a sudden, they started to think about all these things they could do with it. So they thought about, well, I can make lemonade, and I could do all these things. But the funny thing is, the fruit was the same, right? The fruit didn't change. What changed was the context. As soon as they realized they weren't oranges, they were lemons, all of these possibilities became clear. And when I think about this, I think about tools like ChatGPT, right? The tool is the tool. That fruit's not going away. We can't chop the ChatGPT tree down and ban it. Kids are always going to have access to it. But how do we think about it? Do we think about it as a tool that is designed to enable cheating? Or do we think about it as a tool that assists learning? The context makes all the difference. How we think about it allows us to come up with ideas for how to use it. And so we've talked about ChatGPT, we've talked about curriculum, we've talked about learners. But ultimately, in the age of ChatGPT, care and empathy and how we know our kids become essential intelligences. Those are the important things. And as I wrap up, I want to wrap up with a story that some of you may be familiar with, this idea of stone soup. So a bunch of soldiers come to this village and they say, we're starving. And the villagers say, well, we have nothing here. And they said, that's okay, we'll make stone soup. So they get a cauldron, they fill it with river water, they put some stones in it, and they taste it, and they say, oh, it's a little thin. It needs something. And so someone says, well, I've got some spices, and they bring the spices in. And some other people say, oh, that reminds me, I have some vegetables. Others decide to bring other things, and eventually all the villagers contribute something to this stew, and they have this wonderful stone soup. And they say how delicious this soup is that the soldiers brought. But of course, the funny thing is the soldiers didn't bring anything, right? They just brought the stone. All that other stuff was there in the village to begin with. But what's the lesson? To me, the lesson is without those strangers coming to town, no soup gets made. All of that stuff was there, but they needed someone to bring all of it together. That's who you are. Teachers bring the stone. We're at the heart of the student-centered classroom. If we want to create a classroom where we engage kids in doing things that they love, in giving them a mission to change the world, to do something that they care deeply about, that doesn't happen without us. So yes, we should be giving students big challenges and empowering them to do that important work and to be autonomous learners. But we're the ones who kind of have to make that happen. And so I would just leave you with these things to think about. As the teacher, bring the stone. Be the catalyst for powerful change in your classroom. You're not bringing them the soup already made. Your job is to get to know your kids, to bring out the skills and the talents that they already have. They may not even realize they have them. And the stew might be different every year. But your job is to help bring all of that together and make something that everybody can enjoy. Give them a map. Give them a framework. Give them some flexibility within some structure. And finally, remember the lemons, right? Any tool, it's neither good nor bad. It really depends on how do we think about it and what's the perspective that we bring to it. So with those three things, I think we'll be fine. We have all of that. So I want to thank you. And,
PT wrote this talk.
okay, now that's not true.
I helped.
Yes, yes, you did help. Thank you very much. I appreciate it.